My dear students, today we are discussing about the business economics and financial analysis subject. In this particular subject, third unit, session 3, we are going to discuss. Then what is the topic today we are discussing is returns to scale, different types of production functions. Returns to scale and different types of production functions as per the JNTH syllabus. Then returns to scale comes under the long run production function. Returns to scale is the long run production function. Different types of production functions. Different types of production functions. What we are discussing return to scale. Return to scale is how it will be influenced production in the long run. Different types of production function means we are discussing about the Cobb-Douglas CES production functions. Now we are going in detail one by one. So first we should go through the returns to scale. Returns to scale is definition. It refers to the degree by which the level of output changes in response to a given change in all the inputs in a production system. What is the meaning of returns to scale? The meaning of returns to scale, it refers to the degree by which the level of the output changes in response to a given change in all the inputs in a production system. So that means when we are giving the degree by which the level of the output changes in the response to changes in the inputs in the production system, that is called the returns to scale. Then types of returns to scale. Types of returns to scale we divided into three types. What are that? First one is constant returns to scale. Second one is decreasing returns to scale. Third one, increasing returns to scale. Types of returns to scale we divided into three types. What are that? Constant returns to scale, decreasing returns to scale, increasing returns to scale. What we learned in this slide, we have learned about the definition of returns to scale. Then we learned about the types of returns to scale. How many types? Three types. What are that? Constant, decreasing, increasing returns to scale. Then what are the characteristics of the constant returns to scale? What are the characteristics of the decreasing return, increasing returns to scale? First, constant returns to scale. If a proportional increase in all inputs yields an equal proportion increase in output. That means if the proportionate increases means both labor and capital are increased in the same proportionate, then the input yields an equal proportion of the output. The input yields an equal proportion of output. That's why alpha plus beta equal to 1. So that's why we called it as a constant returns to scale. Then what is the example for this constant returns to scale? The constant returns to scale is, example is, if labor and capital are doubled, then output is also doubled. That is called the constant returns to scale. Then the second one is decreasing returns to scale. Decreasing returns to scale means a proportional increase in all inputs, but the yields is a less than proportional increase in output. Yields a less than proportional increase in output. Example, if labor and capital are doubled, then output is less than double. Whereas in the constant returns, if labor and capital are doubled, then the output is also doubled. Here, if labor and capital are doubled, then output also less than the doubled. So first one is constant returns to scale, second one to decreasing returns to scale, third one increasing returns to scale. Increasing returns to scale means if a proportional increase in all inputs yields and more than proportional increase in output. If a proportional increase in all inputs yields more than proportional increase in output. Example is, it is greater than 1. If labor and capital are doubled, then output is also more than doubled. Output is also more than doubled. So first what we learned? We learned the definition of returns to scale. What is the meaning of returns to scale? The meaning of returns to scale, it refers to the degree by which the level of output changes in response to the given change in all inputs in a production system. Then types of returns to scale we discussed. How many types we discussed? 3 types. What are that? Constant returns to scale, decreasing returns to scale, increasing returns to scale. Then again we are going for individually. Constant returns to scale means proportional increase in all inputs yields an equal proportional increase in output. If a proportional increase in all inputs yields an equal proportional increase in output. Example is, if labor and capital are doubled, then output also doubled. That means, what is the meaning it indicates? Labor and capital are doubled means alpha plus beta equal to the 1. Whereas decreasing returns to scale means if proportional increase in all inputs yields a less than proportional increase in output. Example, if labor and capital are doubled, then output is less than doubled. Output is less than doubled. Then the third one is increasing returns to scale. If a proportional increase in all inputs yields and more than proportional increase in output. Example, if labor and capital are doubled, then output is more than doubled. If labor and capital are doubled, then output is more than doubled. Then the graph's returns to scale we divided into the 3 types. What are that? Constant, decreasing and increasing. Just now we discussed about the 3 types of returns to scale. So that particular definitions and example we are showing in the form of the graphical representation. So that means, you see, try to understand the constant returns to scale. All the proportionate of the differences 50, 100 and 200, A, B, C. The difference in between them is similar. Whereas decreasing returns to scale means it is reducing 50 to 90, 90 to 125. Increasing returns to scale means the proportionate of the increase in all inputs doubled, then the output is also doubled in the increasing returns to scale 50, 150 and 400. So from this particular graph, returns to scale is what it indicates: constant returns to scale, decreasing returns to scale and increasing returns to scale with a graphical representation. Then, so now we discussed about the long run production function. In the previous sessions, what we discussed in the previous sessions is short run production function. Short run production function example is law of variable proportion. Long run production function is law of returns to scale. Then what is the difference between short run production function and long run production function? We should go individually, one by one. So basis for comparison: short run production function long run production function. So what is the meaning of short run production? The meaning of short run production function, it alludes to the time period in which at least one factor of production is fixed. At least one factor of production is fixed. One factor of production is fixed means how many total productivity factors? 4. What are that? Land, labor, capital, organization. So in the short run production, what are the land is fixed, capital is fixed, organization is fixed, only labor is changed. That is, only one factor is changed in the short run production function. Why? Because the employer can add the additional number of laborers in a short span of the time. Whereas in the long run production function, it connotes the time period. Why? Because in the time period in the long run, in which all the factors of production are variable. All the factors of production are variable. All the factors of production are variable means land, labor, capital, organization. All these 4 productivity factors are variable in the long run, whereas in the short run production function, only labor is variable. The remaining 3 variables like land, capital, organization, these 3 are the constant. Only labor is variable. Whereas in the long run production, all the 4 productivity factors are variable. Then short run production function, what is the law? The short run production function, what is the law? Short run production function, the law is the law of variable proportions. And whereas in the long run production function, law of returns to scale. Law of returns to scale. Then what is the scale of the production in the short run? The scale of the production in the short run is no change in scale of production. No change in scale of production. No change in scale of production. Then long run means change in scale of production. Change in scale of production. What is the meaning of scale of production? Means increasing the output. Whereas in the short run production, after certain labor, the output level will not be increased. It may be constant or it may goes to the negative. But whereas in the long run production function, the change in the scale of the production. Then what is the factor ratio in the short run production? Factor ratio means it is changes. It is changes. Whereas in the long run production function, it does not change. It does not change. It is fixed. Long run production, the factor ratio is fixed. Whereas in the short run production function, the factor ratio is changes. Then another difference is entry and exit. Entry and exit. Entry and exit. Entry and exit in the short run production function. There are barriers to entry and the firms can shut down but cannot fully exit. Firms can shut down but cannot be fully exit. So entry and exit means there are barriers to entry and the firms can shut down but cannot fully exit. Whereas in the long run production function, firms are free to enter and exit. Firms are free to enter and exit. So totally how many differences we are classified? Basis for comparison, totally 5 variables for 5 components. What are that? First we distinguished the meaning. What is the meaning of short run production function? What is the meaning of long run production function? Then what is the law of short run production function? Then what is the law of long run production function? Then scale of production in the short run and long run production. What is the factor ratio in the short run and long run? What is the entry and exit in the short run production function and long run production function? So the basis for comparison is clearly indicating that short run production function and long run production function. So what we learned up to now, we learned about the long run production function. What is the example of the long run production function? Returns to scale. In the previous sessions, what we learned? Short run production function. What we learned in the previous session? Short run production with the concept of law of variable proportions. Law of variable proportions. So law of variable proportion is the short run production function. Law of returns to scale is the long run production function. So what we learned up to now, we learned about what is the meaning of returns to scale. What is the meaning of returns to scale? Definition of returns to scale. Then types of returns to scale. How many types we discussed? 3 types. What are that? Constant returns to scale, decreasing returns to scale, increasing returns to scale. These 3 types of returns to scale we are showing with the help of the graphical representation. With the help of graphical representation. These graphs clearly indicates what is the difference between constant, decreasing, increasing returns to scale. Then we learned about the differences between short run production function, differences between long run production function. What is the difference between short run and long run production? On what basis? On the basis of the 5 variables. What are that? Meaning, law, scale of production, factor ratio, entry and exit. Meaning, law, scale of production, factor ratio, entry and exit levels. So up to now we completed the short run and long run production function. In the short run production we are taking the example of variable proportion with suitable diagrams and stages, and what is the conclusion about the law of returns to scale. Returns to scale is definition, types of returns to scale, and each stage we discussed, then graphical representation, then what is the difference between short run and long run. For examination point of view, my dear students, please go through each and every slide with systematic manner and understood the concept. It is very easy to understood and remember the concepts with suitable examples. Now we are going to the another topic, that is the different types of production functions. Different types of production functions. Now we are going in detail. So what are the different types of production? Up to now what we discussed? We discussed about the short run production function and long run production. Different types of production functions. Next we are discussing what are the different types of production functions. The different types of production function. The first one is Cobb-Douglas production function. Cobb-Douglas production function. Type of, it is a type of an empirical production function. Empirical, what is the meaning of empirical? The meaning of empirical means collection of data. On the basis of the collection of data, we are analyzing and we are estimating the production function. So that's why the Cobb-Douglas production function is an empirical production function. Who proposed this concept? Proposed by Wicksell. This concept proposed by Wicksell. And who tested against the statistical evidence? Charles W. Cobb and Paul Douglas. Who tested against the statistical evidence? Charles W. Cobb and Paul Douglas. Then what is the equation? Then what is the equation of the Cobb-Douglas production function? Cobb-Douglas production function equation equal to Q equal to A into L, L to the power of B, K 1 minus B, K 1 minus B. What is the Q indicates? Q indicates total output, L indicates units of labor, K indicates units of capital. Capital A indicates constant. Then capital B indicates the parameter. A parameter. Now you clearly understood. Cobb-Douglas production function is an empirical production function. It is proposed by Wicksell and tested against by the Charles Cobb and Paul Douglas. Then what is the equation? The equation is Q equal to A into L to the power of B into K 1 minus B. What is the each variable indicates? Q indicates the total output. L indicates the units of labor. K indicates the units of capital. A indicates the constant. B indicates a parameter. Whatever the parameter we are taking, that can be analyzed. Then, what are the properties of the Cobb-Douglas production function? What are the properties of the Cobb-Douglas production function? The Cobb-Douglas production function properties is, first one is, it should consist or both labor and capital should be positive for Q to exist. What is the meaning of Q? Q means total output. What is the meaning of Q? Total output. So first property is labor and capital should be positive for Q to exist. Then the second property is B plus 1 minus B equal to 1. What it assumes? It assumes only constant returns to scale. It does not supporting the increasing returns to scale or decreasing returns to scale. It does not support increasing returns to scale and decreasing returns to scale. What it assumes? It assumes only the constant returns to scale. So, first property is both labor and capital should be positive for Q to exist. Second point is B plus 1 minus B equal to 1. It assumes only constant returns to scale. It does not support increasing or decreasing returns to scale. It does not support increasing or decreasing returns to scale. Cobb-Douglas equation written equal to the Q equal to A into L to the power of alpha and K to the power of beta. So L to the power of alpha, K to the power of beta. L means labor, K means capital. So what alpha indicates? Labor. Labor indicates that wage share by total income. Wage share by total income. Out of the total income, what is the wage share? That is indicating the alpha. Then beta. Beta, what it indicates? Capital share. Beta means capital. K means capital. Beta means beta equal to capital share by total income. Capital share by total income. Then what each and every variable indicates in this particular equation? Q equal to the total production, L equal to the labor input, K equal to the capital input, A equal to the total factor productivity. A equal to the total factor productivity. Then alpha and beta are the output elasticity of labor and capital. Alpha and beta are the output elasticity of labor and capital respectively. So my dear students, please once again remember the properties. Both labor and capital should be positive for Q to exist. Beta B plus 1 minus B equal to 1. It assumes only constant returns to scale. It does not support increasing and decreasing returns to scale. It can be written in the form of a Q equal to A into L to the power of alpha, k to the power of beta. What is alpha indicates? What is the beta indicates? Alpha indicates the wage share, beta indicates the capital share. Then what is the q and L indicates? Q indicates the total production, L indicates the labor input, K indicates the capital input, A is the total productivity factor. Total factor productivity. Then the properties is continued. If alpha plus beta equal to 1, it is a constant returns to scale. If alpha plus beta greater than 1, it is increasing returns to scale. If alpha plus beta less than 1, it is decreasing returns to scale. It is Q equal to A into L to the power of B into K to the power of 1 minus B. So these are the properties of the Cobb-Douglas production function. Then what are the limitations of Cobb-Douglas production function? It cannot show, first limitation is, it cannot show marginal product of an input passing the 3 stages of production. Second one is, it assumes constant returns to scale. Certain production function cannot be increased in the same proportion. Difficulty in measurement of various inputs. Difficulty in measurement of various inputs. Then it assumes there is a fixed relation of raw materials and output. So then what are the limitations of Cobb-Douglas? It cannot show marginal product of an input passing the 3 stages of production. It assumes constant returns to scale. Certain production function cannot be increased in the same proportion. Difficulty in measurement of various inputs. It assumes there is a fixed relation of raw materials and output. Then what are the uses of Cobb-Douglas production function? The uses of Cobb-Douglas production function is, it is an empirical study of manufacturing industries and inter-industries comparison. Then the second usage is, it determines the relative shares of labor and capital into total outputs. It determines the relative shares of labor and capital into total output. And it is used to proving the Euler's theory. Euler's theory. Economists have to extended Cobb-Douglas function to more than 2 functions. Cobb-Douglas have function to more than 2 functions. And it is also used for the forecasting of GDP and income shares. It is used for the forecasting of GDP and income shares. So this is the Cobb-Douglas production function. So what we discussed about the what is the meaning of Cobb-Douglas production function, what is the formula for Cobb-Douglas production function, then what are the properties of Cobb-Douglas production function, then what is the limitations of the Cobb-Douglas production function, then uses of Cobb-Douglas production function. Then the next topic is, so first one, different types of production functions we are talking. First one is the Cobb-Douglas production function. Now we are started about the second one. What is the second one? Leontief input and output analysis. Leontief input and output analysis. In this Leontief input and output analysis, what we are discussing in this section, we are discussing about an important economic applications of matrix inverses and matrix multiplications. Matrix inverses and matrix multiplications. What is the major role? Matrix inverses and matrix multiplications. And this branch of applied mathematics is called input-output analysis and was proposed by Vasily Leontief. He is the Nobel Prize in Economics in the years 1973 for his work in this particular area. What is that? Input-output analysis. What is that? Input and output analysis. Then what is the Leontief production function? The Leontief production function is Q equal to the minimum A into capital B into labor. So capital and labor are perfect complements and cannot be substituted. So that means no MRTPS, no slope. No MRTPS, no slope. Then capital and labor are used in fixed proportions. Both inputs needed to produce output. Both input needs to output. Then CES production function. What is that? CES means constant elasticity of substitution production function. X equal to y kc minus alpha plus 1 minus k into L minus alpha. That means minus V by alpha. What is the X indicates? Output. C indicates capital. L indicates labor. Omega indicates efficiency of parameter. That is, we called it as a scale effect. Then K, capital intensity factor. Then K minus 1, labor intensity factor coefficient. V, degree of returns to scale, alpha, substitution parameter. So this is the constant elasticity of substitution of production. This is the formula. Now we are going for the, what is the properties of constant elasticity of substitution product. It is a homogeneity. Homogeneity means the functions of homogeneous is degree. Marginal products are positive. Then capital and labor are complementary inputs. And the another property is negative slope and strict convexity. Negative slope and strict convexity. It proves the Euler theorem. The constant elasticity substituted is Euler's theorem. And diminishing returns to each input for all positive levels of input. Then elasticity of substitution is constant but not unitary. These are the properties of the constant elasticity of substitution production. Then what is the difference between Cobb-Douglas production function and constant elasticity of production function? Cobb-Douglas production function is applied to the nature of all industries, whereas it is more or general. Whereas Cobb-Douglas production is convenient and international and inter-industry comparison. Whereas it covers the all types of returns, CES. It is the most commonly used function in the field of econometrics in the Cobb-Douglas function. Whereas constant elasticity substitution product is used in the account number of parameters. Whereas it is used generalized in case of n productions, it is used for easy estimations. And the unknown parameters of A and P in the function can be easily computed. Whereas in the CES function is free from unrealistic assumptions. It is more empirical in the research, where in the Cobb-Douglas production function. So these are the differences between Cobb-Douglas production function and constant elasticity of substitution. So Cobb-Douglas production function, how many merits we are discussing? 8 merits we are discussing. And whereas in the constant elasticity substitution, we are discussing 6 differentiations. So my dear students, in this particular session, we are talking about what we are talking? We are talking about the returns to scale. Then we are talking about the different types of production. systems. Different types of production functions we are discussing. So my dear students, on the basis of the syllabus, we are discussing about the returns to scale and different types of productions. Different types of productions, how many types we discussed? We discussed 3 types. What are that? Cobb-Douglas production function, Leontief production function, constant elasticity of substitution production function. Then my dear students, for examination point of view, especially in the examination, several times they asked about the define Cobb-Douglas production function with suitable example. Second one is explain constant elasticity of substitution production function with suitable diagram and examples. Then the third one is distinguish between constant Cobb-Douglas and CES production function. So my dear students, these are the major differences and major different types of production functions. For examination point of view, if you observe the previous question papers, mostly they are emphasizing these 2 topics. What are that? Cobb-Douglas and CES production function. In the last year supplementary question paper, they asked about what is meant by Cobb-Douglas formula. Formula asked in the short answer question. And compared to the essay type questions, asked about the Cobb-Douglas production function with suitable examples and CES production function with suitable diagrams and examples. So my dear students, in this session we learned about the topics, all the returns to scale and production functions. Different types of production functions we are discussing. Please go through each and every slide and it will be useful for examination point of view. Thank you, my dear students.